Good morning, everyone. In today's lecture, we have to discuss the unit number one, that is nothing but the basic concept, that is the introduction of that stability and the subject of the power system stability. Okay, so in terms of that stability point of view, the whenever we have to talk about any power systems that are related with any electrical engineering, that in terms of the power system, the synchronization between the generation side to the distribution side or to the load side, that should be the maintained. If that equilibrium or the synchronization is not maintained, that whole the system should be the collapse, or it should be directly affect the performance on the generation side also, and the performance on the load side, that is the different the instrument that are connected to the load side, that also affected. That means that the system should be the goes to the unstable condition. Okay, so in this unit we have to discuss the all about the basic concept, what is nothing but the definition of the stability, what we, second is nothing but the their classification of that stability, there are stability limits, there are three-phase machine equations, then Park transformation, then the transient and the sub-transient state analysis, and their phasor diagrams that we have to discuss in the unit number 1. So let us discuss what is nothing but the first the stability. क्या stability का meaning क्या होता है? So basically the stability is nothing but what? It's ability of that electrical power system for the given initial operating condition, so that to regain its state of operating equilibrium after being subjected to the physical disturbances, with all the system variable are bounded, so that practically the entire system should be remain intact. So basically what is meant by power system stability? It's ability of the system to regain its equilibrium position irrespective of the physical disturbance which are occurred on the system, so that the entire system should remain intact. Means what? Whenever there is a physical disturbance like the sudden change in the load or the sudden frequency change, or because of that internal or the external fault on the power systems apparatus, the stability of that or the equilibrium of that system, electrical power system, should be the affected. If that equilibrium, it should regain its original position after the physical disturbance should be the cleared, that system is called as power system stable. Means what? The stability is a condition of the equilibrium between the opposing forces. Instability result when the disturbances leads to the sustained imbalance between the opposing force. So basically it's a condition for the equilibrium between the opposing forces, so that it's regain its original position to leads to the sustained imbalance between the opposition forces. The stability problem is generally concerned with the behavior of the synchronous machine and their disturbance, because the synchronous machine is nothing but we may call it nothing but what? The stability of the power system. So basically that stability problem are generally concerned with the behavior of the synchronous machine after the disturbance. So the power system stability is ability of the electrical power system to regain its original position irrespective of the different internal or the external fault occurred on the system. After the clearing of that fault, the system should be come back to their original position. Means we can say that that system should be the stable one. If that system should not, if that electrical system it should not regain its original position, then we may call it study but the system is study but the unstable one, or we may study but the not in the synchronization with a generation side or the distribution side. That's why that stability problem is very much important with the behavior of the synchronous machine after the disturbance. Means what? As compared to the synchronous machine which are runs under the electromagnetic, that is which are generally working on the principle of the magnetic locking. If there is a, means what? Magnetic locking means what? It generally is in the stator and the rotor are generally working on the synchronization between at its same speed. If there is an abnormality, it should be the occurred or the any load changes or the any internal or the external or the frequency change or the load angle change, anything disturbance should occur on that motor, supposed to be the synchronous motor, the rotor speed should be the lower down. And if the rotor speed should be the lower down, it's again reaches to the that is नॉट बट asynchronous motor. अगर asynchronous motor उसको फिर से synchronous motor में run करना है तो मुझे क्या लगेगा? We require the excitation system. Means what? The system or the ability of that system to regain its original position, but not means what? To regain its in the synchronization, to maintain the system in the synchronization of the stator and the rotor after the disturbance. That is that behavior is generally same as the stability point of that stability behavior of that electrical system. That's why we may also call it the power system stability is also called as the synchronization of that synchronous motor. Okay, so basically in terms of the power plant, the several synchronous generators are generally connected. Synchronous generator connected hai at a bus having the same frequency and the phase same sequence as the generator. Same frequency, same phase sequence. If that same frequency should be the affected by the any internal or the external reasons, the synchronous motor which are working on the synchronous speed, it should be the directly affected. Therefore, for the stable operation, we have to synchronize the bus with the generator over the entire duration of that generation and that transmission. Hence, the power system stability is also referred as a synchronous stability, and it's defined as ability to retain. That is nothing but the ability. क्या हो रहा है? Ability is nothing but to retain the synchronism after having the underlog the different some disturbance due to the switching on off load or due to the line transistence. Means what? Switching के हिसाब से that is nothing but the frequency of that switching, line frequency, that is nothing but the phase sequence. अगर वो change होता है तो automatically the synchronization should be affected. That's why that power system stability is also called as a it's nothing but the synchronous stability, and it's defined to ability to retain their original position or to retain their synchronization after undergone the some disturbance. Disturbance होने के बाद में वो stability में फिर से अपने original position पे आ रहा है, वो system का अपन बोलेंगे synchronous stability or power system stability. The stability limits define the maximum power permissible to flow through the particular point of that system for which it's subjected to the line disturbance and the faulty flow of power. Means what? Stability limit क्या define कर रहा है कि maximum power permissible to the flow through the particular part of the system for which fault or the disturbance should be the occur. Means what? अगर steady state stability, sorry, whenever we have to talk about the stability limit, means what? एक particular limit तक कितना maximum power flow हो रहा है at a point of disturbance, वो limit को बोलेंगे अपन stability limits. Okay, so this is nothing but the power definition of that power system stability, and the problem facing while to maintain the system should be the stable one, or this nothing but the power system should be stable one. Secondly, the power system stability is also called as nothing but the synchronous stability. How can we classify the power system stability? The power system stability are generally classified by depending upon some assumptions, like first the physical nature of in the resulting instability, second size of disturbance considered, third processes and the time span involved in the stability. So this is nothing but all the classification of that power system stability are generally dependent. First of physical nature, second is nothing but the size of disturbance, third processes and the time span involved in that of that power system of the electrical system. So basically the power system stability are generally classified generally is that in the three types. First is steady state stability, second is transient stability, and third is the dynamic stability. We have to discuss the power system stability classification in detail. Of out of that, uh, it should be the generally the steady state or the transient or the dynamic one. It's a but the generalized classification of that power system stability. But basically that power system stability are generally classified depending upon the rotor angle change, rotor angle stability, frequency stability and the voltage stability. So ये उसका तीन टाइप्स है. एक तो रोटर एंगल स्टेबिलिटी आएगा, frequency stability, that is but a detailed classifications of that power system stability. First is rotor angle, second frequency, and third is nothing but the voltage one. Okay. So in terms of that rotor angle stability, it's again classified into the small and the transient stability, and that is study but the short term stability. Again the frequency is study but the large disturbance stability, and again is study but the long term stability है ये शॉर्ट टर्म स्टेबिलिटी है, ये लॉन्ग टर्म स्टेबिलिटी है. Whereas voltage stability में again फिर से large disturbance stability, small disturbance, small or long का it's again the short time and the long term stability is there. Okay, so basically that stability it should be the classified into the three types: steady state, transient and the dynamic stability. नंबर वन, स्टेडी स्टेट. अब स्टेडी स्टेट का मीनिंग क्या होता है? इट रेफर्स टू द एबिलिटी टू रिगेन इट्स सिंक्रोनाइजेशन आफ्टर स्मॉल एंड द स्लो डिस्टर्बेंस. अब स्मॉल और स्लो डिस्टर्बेंस क्या रहेंगे? सबसे पहले स्टेडी स्टेट आएगा, बाद में ट्रांसिएंट आएगा और बाद में डायनामिक आएगा. ओके, द स्टेडी स्टेट इज स्टडी बट स्मॉल एंड द स्लो डिस्टर्बेंस सच एज ग्रेजुअल पावर चेंज हो रहा है, नॉर्मल लोड फ्लक्चुएशंस हो रहा है, नॉर्मल फ्रीक्वेंसी फ्लक्चुएशंस हो रहा है, ऑटोमेटिक वोल्टेज रेगुलेशन में अपन टैप चेंजिंग यूज करते हैं तो ऑटोमेटिक वोल्टेज अप एंड डाउन होता है, उसके हिसाब से दैट इज बट स्टेडी स्टेट स्टेबिलिटी पिक्चर्स में आता है. So it only be considered only during the very gradual or the indefinitely small power changes. Means what? For the small and the gradual changes in the load or in the power, in that case the steady state stability should consider. So in case of that power flow through the circuit exceeds the maximum permissible limit, then there is a chance that particular machines and the power of that machine will changes to operate in the synchronization and result in a not disturbance. In such situation steady state limit reaches its state has to be reached. Means what? Whenever there is a power flow through the circuit exceeds the maximum power permissible, means what? 100 मेगावाट का permissible था, 100 मेगावाट के ऊपर अगर वो पावर कंजम्पशन कंज्यूम कर रहा है, then there is a chance that particular will machine should comes affected their synchronization, result into the more disturbance होगा. इस केस में जो steady state limit reach हुई है that is nothing but the steady state limit of that power system. Okay, the steady state limit refers to the maximum amount of that power that is to be permissible through the system without the loss is steady state stability. Means what? The limit maximum power which are generally flow at a point at which the steady state stability should not affected, should not goes beyond the synchronization. अगर beyond the synchronization जाएगा तो unsynchronization में आएगा, unsynchronization में आ गया तो system unstable हो जाएगा. Okay, so that is nothing but the steady state stability limit refers to the maximum power flow at a point that the permissible through the system without the loss its steady state stability. Dynamic stability. अब dynamic stability क्या है? It's nothing but an extension of that steady state stability, which are generally concerned to the small and gradual in the case of the steady state, whereas we study but the small disturbance lasting for the long time. वहाँ पे small case के लिए था, जो भी changes आ रहे थे vary for the short duration of that time. यहाँ पे is nothing but the for the long duration of that time, the dynamic stability should be disturbance are for the long duration of time. which are including of that automatic control devices. Dynamic stability, which are generally denotes through the artificial stability given to the inherently unstable system by the automatically controlled means what it generally which are extension of that small steady state stability, and it is generally occurred for the long duration as compared to the steady state, having the duration is nothing but the 10 to the 30 seconds, whereas less than 10 seconds it's nothing but the steady state stability conditions is there. Okay, नंबर 10 ट्रांसिएंट स्टेबिलिटी. अब ट्रांसिएंट स्टेबिलिटी क्या बोलता है? The system it withstand a transient condition following the major disturbance. Means what? जितना भी मेजर डिस्टर्बेंस आ रहा है उस केस में जो भी ट्रांसिएंट आ रहा है, ट्रांसिएंट केस में अगेन द सिस्टम शुड बी कम बैक टू देयर ओरिजिनल पोजीशन. वो केस में अपन उसको बोलेंगे द सिस्टम इज ट्रांसिएंटली स्टेबल वन. ट्रांसिएंटली स्टेबल वन मींस जो भी फ्लक्चुएशन स्पाइक्स एंड अप एंड डाउन फॉर द लॉन्ग ड्यूरेशन आ रहे हैं बिकॉज ऑफ दैट मेजर डिस्टर्बेंस फॉर द लॉन्ग टाइम, इस केस में अगर सिस्टम फिर से रीगेन करता है देयर ओरिजिनल पोजीशन और देयर सिंक्रोनिज्म, देन द सिस्टम इट्स कॉल्ड एज ट्रांसिएंट स्टेबल वन. ओके, this stability are generally deals with a this stability are generally deals with a large change in the system, likely sudden application or the removal of the load. अगर इमीडिएटली अगर आपने लोड निकाल लिया या फिर सडन लोड ऐड कर दिया, स्विचिंग ऑपरेशन अगर ऑन था तो ऑफ कर दिया, ऑफ था तो ऑन कर दिया, या फिर ट्रांसफार्मर को कनेक्टेड कर दिया पैरेलल में इमीडिएटली और द लाइन फॉल्ट आ गया है, लॉस ड्यू टू द एक्साइटेशन लॉस हो गया है, तो उस केस में क्या आएगा? ट्रांसिएंट आएगा किस पिक्चर में, तो सिंक्रोनाइजेशन इमीडिएटली डाउन आएगा. तो ट्रांसिएंट स्टेबिलिटी शुड बी comes into the plane for sudden load changes, sudden conditions, sudden disturbance, ये सब आता है transient conditions में. Okay, so that ability of that system to regain its synchronization following the disturbance for the long period. Whenever there is a term long period will be there, then it's called as transient stability. Thus, the maximum power that is permissible through the network without the loss its stability following the sustained period of that disturbance is referred to that transient stability of that system. Okay, so going beyond that maximum permissible value, it is to be the unstable one or the unsynchronous one, that is studied by the transient stability. So depending upon the classification, first steady state, second dynamic, and third is studied by the transient. Whenever the term steady state is there, it's for the small and the slow disturbance. Dynamic, it's an extension of that steady state which is having the more for the higher period as compared longer period as compared to the steady state, whereas transient one, sudden load changes or sudden disturbances for the longer period, that is called as transient stability. In the next lecture we have to in the that is but the power system stability limit. So stability limit क्या बोल रहा है? तो stability limit are generally defined study but the maximum power that can be the transfer in the network between the sources and the load without the loss of synchronization, that's called as stability limit. Means what? स्टेबल कंडीशन में कितना मैक्सिमम पावर फ्लो हो रहा है. मीन्स व्हाट? अगर मेरा रेटिंग है लोड का 100 मेगावाट का लोड है और 100 मेगावाट का दैट इज 150 मेगावाट का जनरेशन है. अब मुझे 100 मेगावाट अगर लोड मैं कंज्यूम कर रहा हूँ एट अ स्टेबल कंडीशन पे, तो हो गया उसका स्टेडी स्टेट लिमिट इज स्टडी बट द स्टेबिलिटी लिमिट उसकी कितनी है? 100 मेगावाट. तो अब में स्टेडी स्टेट स्टेबिलिटी लिमिट क्या होगा? Whenever there is a load increases, gradually that steady state condition limit the maximum power that can transfer without become unstable. Steady state small और gradual increase अगर load हो रहा है फिर भी अगर system stable रह रहा है, उस केस पे जो steady state power consume या फिर drawn हो रहा है उसको अपन बोलेंगे steady state stability limits. Okay, second transient stability limit. अब transient for that sudden change or the large disturbance. अब sudden change और large disturbance में जो maximum power flow हो रहा है without the losing their synchronization or without losing their unstable condition, that is called as transient stability limit. Number third, dynamic stability limit. Dynamic stability limit increases significantly if the increase in the field current or the adjustment in the speed setting occurs simultaneously. Means what? It's nothing but extension of that steady state है. ये डायनेमिक में क्या हो रहा है? स्मॉल एंड द रेगुलर चेंजेस, okay, small and the continuous changes in the system, that's called as dynamic stability. If the fee increase in the field current or the adjustment in the speed setting occurs simultaneously with the increase of that load from the use of that AVR and the speed conveyor, hence the limit under this condition called as dynamic stability limit. Okay, so here we concluded that is introduction, that is but the first that we have to discuss on today's lecture. First is that but what is the power system stability, what is the definition of that, then their problem facing during the power system stability. Third, classification of that stability, that is a first is steady state, second is transient one, third is that but the dynamic one, and their limits, stability limits. In next lecture we have to discuss the basic synchronous machine transformation representations with reference to the stability point of view. Thank you so much.